All right, so here is number 6 off of your email. Well, hello, hope all is well. Hope you're doing all right. But here's number 6. I believe this was your, yeah, number 6. He had 3, 5, and 6. So this is number 6. Hold on, 6. That's at 3, 5. Okay, good. So this was number 6. It actually came out of 4.2, and it was 4221 MI. So it says use the summation formulas to rewrite. And so my numbers may be a little bit different than yours, but this number, the formula I pulled, very similar to what you have. We have a summation of 8i plus 3 over n squared, going from 1 to n. And so the summation formulas were in that section 4.2. And here they go. Well, let's do it like this. So if you just have a constant and you're going from 1 to n, that's going to be that constant times n. If you have I going from 1 to n, then you can substitute I with n times n plus 1 over 2. If you have I squared, you can substitute that with n times n plus 1 times 2n plus 1 over 6. And then if you have I cubed, you have n squared times n plus 1 squared over 4. All right, so if we look at what we have I right here that we can substitute in n times n plus 1 over 2. And then we have the constant, which is 3, and we can just substitute that n for the constant. Notice that if we just have a constant, you can do c times that n. All right. So from there, we can go ahead and look to simplify. So if we were to look at this, we have 8 times n plus 1 over 2 plus 3 over n. I brought that 1 over n squared to the front because remember, we substituted in for I, not for n. So substituting for I, that gives us n times n plus 1 over 2. And then, like I said, that's plus 3n right there. And so now we can simplify. Okay, that 2 goes into the 8, leaves you with 4. And on the outside of the parentheses, we have 4n, so we can distribute that into the parentheses. So that's 4n times n, which is 4n squared. 4n times 1 is 4n. And then plus this 3n, which is still here. Combine your like terms. 4n plus 3n is 7n. Now take your 1 over n squared, distribute, and that'll be 4n squared over n squared plus 7n over n squared, and cancel out and reduce, and that leaves you with just 4 plus 7 over n. Right? I think you said that was the main problem you had with this problem. So that would reduce down to 4 plus 7 over n. But this would be our S of n. S of n, excuse me, not sub n, but S of n. And so from there, you would just plug in the values they asked you to plug in. Like the first one's 10. So you plug in 10, that'll give you 4.7. Plug in 100, that'll give you 4.07, and so on. All right. So that's that one. Next one, number 3. We got that's 4.4.56. It says find the average value of the function. You know, I think the direction was a little bit longer, but within this interval right here, we have f of x equal to cosine x. And then that interval is from 0 to power over 2. Power over 2 is 1.57. So you're talking about 0 to 1.57. And so the average value formula is 1 over b minus a times the integral of f of x from a to b. So that's what I did right here. A is 0, b is power over 2, and we want to take the integral cosine, which is sine. All right. Then from there, plug in power over 2 and 0 into sine, and do that subtraction. So that's sine power over 2 minus sine of 0. Sine of 0 is 0. That leaves you with sine of power over 2, which is just 1. Or also right here, power over 2 minus 0 is just power over 2. So we have 1 over power over 2, which just turns into 2 over pi, you know, whenever you divide by a fraction, you multiply by the reciprocal, it turns into 2 over pi times 1, which is just 2 over pi. And then that'll give you 0.637 as a decimal. All right, I believe they wanted 3 decimals as your answer. Then from here, it says find the values of x within the interval that we have, which is 0 to power 2. So a couple ways we can find the graph. You can either go to the graph. So if you were to go to a graphing calculator, let's say like Desmos, type in cosine x, and then we're looking for 0.637 for y. So if you go here, see if I can find it, 0.6. I was there. Come on, scroll up a little bit. There we go. 0.637 for y is right here. And you see our value is 0.88. Now this would be good if WeberSign only want 2 decimals, but because they want 3, we would then, you know, we probably have to go to a calculator. So if you go to like something like Mathway, you can do cosine and then do cosine inverse. And that was 2 divided by pi. So cosine inverse is the same thing. If you want to know what is x when y is a certain value, whatever that y is, our y was 2 over pi. So do cosine inverse of that, hit enter, it's going to ask us to evaluate, and see we get the 0.88068. So they just wanted 0.8806. Round at 3 decimal places, that'll be 0.881. All right. So if we go back, that's how I got the 0.881, just doing cosine inverse of 2 over pi. All right. And then the last one, find the values of C by the mean value theorem of the integration. Hold on 1 second. I think that's the right word. Say for integrals, not integration. There you go. Mean value theorem for integrals. So they gave us f of x equal to 3 square root of x. And our interval is from 4 to 9. So here's that formula, the mean value theorem for integrals. You got the integration of f of x from a to b. Then we have f of c, which is this right here. You're just plugging in a c right here in your f of x function. And then times b minus a. So first thing is to find the integration of 3 square root of x from 4 to 9. And so that's what I did right here. So I just rewrote it, that square root as x to the 1/2 power. Brought my 3 to the front, and I found integration by, you know, you add 1 to the 1/2 power. So that's how I got 3 over 2. And then you place that over 3 over 2. But then that 3 over 2, you know, whenever you divide it by a fraction, multiplying by the reciprocal. So that's how I got 2 over 3 out here. All right. So now that can reduce, these 3's out here can cancel. 3 in the denominator, 3 in the numerator. And then I'm plugging in 9 for x. So I brought the 2 to the outside. And then I'm plugging in 9 for x. So 9 to the 3/2 power minus 4 to the 3/2 power. 9 to the 3/2 power reduces to 27. So that's the square root of 9, which is 3. 3 cubed is 27. And the square root of 4, which is 2. 2 cubed is 8. 27 minus 8 is 19. And 2 times 19 is 38. Excuse me. Okay, so now we have 38. That's the integral, or the integration of 3 square root of 2, 3 square root of x from 4 to 9. So it's 38. So now we're plugging in the pieces that we have. So this part is what we just found out. That's 38 equal to 3 square root of c. That's our function with c plugged in for x. And then times 9 minus 4. 9 minus 4 is 5. 5 times 3 is 15. So the right side of my equation, to simplify as much as possible, is 15 square root of c. Divided by 15, I have 38 over 15 equal to the square root of c. You know, so if I erase all this, this is what I have now. And so now I need to take the square of both sides so I can get rid of the square root off of c. Don't forget, whenever you take the square root of both sides to solve, you will always be left with 2 answers, plus and minus. Now we want the answers for C that fit within our integral. So don't forget our integral, or not integral, but interval is 4 to 9. So whatever our answer for C is has to be within 4 to 9. So that's why the negative right here does not work for us, because that would be negative 6.4178, which would be less than 4. But the positive works, which is 6.4178. And so that's our only answer, the positive 1,444 divided by 225. All right. Let me know if you have any questions. Take care.